Most histories about the rise of modern science begin with one of two major events. Number one, the fall of Constantinople in 1453, which caused many Byzantine scholars to flee to Italy, bringing ancient authors with them and enlightening the ignorant Westerners. Or number two, Copernicus's book in 1543, precipitating a drastic change and a major revolution in how people thought about the universe and our place in it. Both statements misrepresent history. The first claim about the flood of ancient authors into the West ignores the fact that most of these authors had been copied and preserved in Christian monasteries since the 5th century, and that Western universities took over the translating and copying of these ancient texts around the 12th century. The Western universities had also been teaching, disputing, and commenting on all the important classic writings long before 1453. Remember, in the last video, you saw that the university was a Christian invention, and throughout the Middle Ages, the universities were run by Christians and supported by the Christian Church. The second misrepresentation about Copernicus ignores the fact that he had received an excellent education at some of the best Christian-sponsored and Christian-run universities at the time. It also assumes that the idea of the Earth orbiting the Sun just came to him out of the blue, instead of simply being the next implicit step to what the Christian scientists had formulated and to what the Christian universities had taught for the past 2 centuries. Copernicus earned his first degree from Krakow, one of the best universities of the time. He then spent 3.5 years at the University of Bologna, one of the best universities in Europe. After that, he spent 4 years at the University of Padua. The notion that the Earth circles the Sun did not come to him out of the blue. Rather, during his superb education, Copernicus was taught the essential fundamentals that led to his heliocentric model. So, here is a brief history of scientific thought leading up to Copernicus. To the ancient Greeks, continuous heavenly motion required continuous force. Each of the planets was thought to have an unmoved mover, a god that corresponded to each entity in the heavens that provided the impetus to keep the planet moving. The Christian belief in one God who created the universe but was separate from the universe, along with the Christian belief in the unity of the heavens and the earth, helped to change our view of heavenly motion and was a crucial step towards modern science. The 4th century Christian bishop Basil of Caesarea was one of the first to use the concept of momentum or inertia to describe the non-duality of the heavens and the earth by imagining a child's top. Just like a top continues to spin long after the initial force is provided to it, the heavens can continue in circular motion long after the first command from God was given to them. In the 14th century, Oxford alum and English Franciscan friar William of Ockham argued similarly to Basil that a body in motion may not require continuous pushing once it had been set in motion by God. His belief that a vacuum existed in space allowed him to extend Basil's idea, stating that the planets remain in motion because there's no friction in the emptiness where the planets orbited. Also in the 14th century, Albert of Saxony, who was a bishop in the court of Pope Urban V, elucidated the motion of the planets with explanations that sound a lot like Newton's inertia, teaching that the motion of the planets could continue from when God first caused them to move because there's no opposite force acting on them. Jean Buridan, rector at the University of Paris, built on this idea, anticipating the concept of inertia and Newton's first law of motion. When moving the celestial orbs, God impressed upon them impetuses which moved them without his having to move them anymore. And these impetuses, which he impressed in the celestial bodies, were not decreased nor corrupted afterwards because there was no inclination of the celestial bodies for other movements, nor was there resistance which could be corruptive or repressive of that impetus. Still in the 14th century, Buridan, along with Nicole Oresme, proposed that the earth turned on its axis. Oresme was a French bishop and an Aristotelian scholar. As an aside, he invented coordinate geometry before Descartes and was the first to use a fractional exponent. Using Aristotle's model of the universe, he proposed that the spheres of air, water, and earth rotated once every 24 hours instead of the outer fiery spheres and the heavenly spheres rotating around this stationary Earth. He explained how this was possible by using the example of two boats traveling smoothly and passing each other. If you're on ship A, watching ship B pass by you, it would look identical whether you were the one moving and B was still, or whether you were stationary and B was moving. In other words, motion is relative. Oresma returned to the ship analogy to answer common objectives to the moving Earth, such as why there's not a constant wind and why arrows fired straight up do not land far away from their origin. If you're inside a ship which is moving smoothly, the air in the cabin is carried right along with the motion and you don't notice a wind. If the air rotated right along with the Earth, then also there would be no wind. And the moving air could also move the arrow along with itself. This would cause the arrow to land in the same location from which it is fired. He understood relative motion well enough to insist that we cannot make any observation that can tell us whether the Earth is moving or whether the universe moves around the Earth. This would remain the case until the mid-1800s. Did Oresma, a Christian bishop, think that a moving Earth conflicted with what the Bible says about the Earth? Well, no, and he wasn't alone. Oresma thought that the Bible was written in common observational language. To us, it looks like the Earth doesn't move, and that's what the language in the Bible reflects. John Calvin believed and taught the same thing, as did Johannes Kepler and Galileo. They all believe that the Bible relates to creation by referring to what ordinary people actually see and observe. Kepler and Calvin thought there was a distinction between the practical experience of our senses and the theoretical knowledge gained by scientists. We still believe this today, as we commonly talk about things like sunsets and sunrises, while at the same time we know scientifically that the Earth actually moves. In the 14th century, Christian university professors began to teach that the sunrise and sunset could be caused by the rotation of the Earth. It was also no longer necessary to assume that the sun circled the Earth. The heliocentric solar system was becoming increasingly plausible. A 15th century German Catholic cardinal, Nicholas of Cusa, also taught that the Earth turned, but took the next step leading to a heliocentric model, pointing out that whatever position one occupies in the cosmos will seem to them like the motionless center, with everything else moving around them. Nicholas concluded that humans cannot trust that we occupy a motionless position relative to the rest of the universe. This idea of relative motion is, of course, a basic tenet of modern science. There is good evidence that Nicholas also believed that the Earth was not at the center of the universe and that orbits were not perfect circles. All of the theorizing of these Christ-believing and Christian-educated natural philosophers, Occam, Burdon, Oresme, Albert, and Nicholas, all of this was known prior to Copernicus and taught at the Christian-centered universities. We also know that Copernicus was aware of Aristarchus of Samos, a Greek astronomer that had proposed sometime around 250 BC a heliocentric model of the solar system. And Copernicus mentions in a letter to Pope Paul III that he knew of other proposals that had the Earth moving. So what did Copernicus actually add to science? He simply proposed a model of the solar system with the sun at the center, not that different from the one Aristarchus had proposed almost 1800 years earlier. Copernicus's prediction mathematics were also not any more accurate than those created by Ptolemy in the 2nd century. His model was not really an improvement. Again, we had no measurement or observation that could definitively distinguish between Ptolemy's geocentric model and Copernicus's heliocentric model until the mid-1800s. Copernicus, like Ptolemy, also had to use epicycles to obtain reasonable predictions and actually ended up needing about the same number of circles on top of circles that Ptolemy needed in his model. Copernicus failed to progress beyond Ptolemy, as he also had the planets embedded in rotating spheres just like the ancient Greeks, instead of the planets being separate, unattached bodies. So keep in mind what Copernicus knew before he proposed his theory. He was taught that the Earth rotated. He understood the concept of inertia and relative motion. Those were well established. And he was aware of other heliocentric models that had been proposed prior to his model. So it's a myth that Copernicus was a lone genius who revolutionized science and began the scientific revolution. He simply took the logical next step by building on what was already being taught in the Christian theologically centered universities, and he proposed a model that really didn't add much to the science of the day. The larger and more important main point, though, is that Christians did not hold back or hinder scientific advancement during the Middle Ages, and in fact, they pushed science forward and prepared the way for the advent of modern science.